Okay. Welcome everybody to Copenhagen University, which has agreed to host this exciting day on new tools for TB. It's a special day for me because I'm from Copenhagen. I studied medicine at this faculty some years ago, and after some years at Fine, I'm now working here in Copenhagen at the Novo Nordisk Foundation Initiative for Vaccines and Immunity. So we're working on airway immunity, we're working on protective immunology around the airways in NIVI, the research organization I work on. We work on TB, we work on group-based streptococcus, we work on flu. And we also do preclinical, but also some clinical development, mainly on vaccines. But it's nice to be able to invite the international crowd around TB when you are all here in Copenhagen. So we're going to have a busy afternoon. We have done this 10 times now, something.
Probably more.
Probably more.
I have done more.
So it's going to be 90 minutes about diagnostics first, then there will be a coffee break, then it's 90 minutes on vaccines, and then 90 minutes on TB drugs. There's going to be a couple of breaks in between. I need to remind myself to say that the toilets are down there and down in the basement. We're at a university, so they can manage capacity between lectures. Let's see how this goes. And apart from that, I think that's it. It's all for me. Just to welcome you all. Luchika, you're next on the program, and you need no instruction to this club, but you're the executive director of Strategic Partnership. You're a Romanian physician, accomplished professional and leader in the global fight against TB and other communicable diseases as well. You're driven by a firm belief that we should never give up on our efforts to end TB, and we will leave no one behind. You're an unapologetic supporter of people affected with TB and a firm believer in innovation, flexibility, change, and also in breaking the rules and thinking outside the box. And Chika, you're dedicated to driving also political commitment, diplomacy, engagement, and accelerate the efforts to it. What was your mind? Friend and my sister.
Yes, thank you. Thank you. And first of all, allow me to say thank you, Morten, for pulling all the strings to make sure we are being hosted here, and for making sure that this takes place. And I also want to thank NIVI for making this happen as well and supporting this, and also the University of Copenhagen that I think is giving us this auditorium, I hope for free. There is space here. If you can move, because there are some colleagues standing and there is space here on the line. There are some spaces in the middle because people usually go on the margins for toilet reasons, I assume. Okay. So while everybody is coming in, because I think it's absolutely amazing. I have to confess, it's overwhelming and amazing to see you all here, to see everybody here. I understood the number of people registered is incredibly high, and I really look at this auditorium and it's spectacular. And somebody who has good skills at taking a selfie, I don't know, Morten, if you can, while I speak here, you take a photo with you here, like the rock stars are doing, you know what I mean? You go to concerts and then the entire, I was at the Ricky Gervais. No, you can't, no, not with
Okay.
you stay here and you do a photo like that with you. And did you do? Let's do it. Let's do it. Everybody, a hands up. So you do. No, you do like that.
Okay, I don't do I'm not teenage anymore.
Okay, like that. Okay.
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 Raise your hands, everybody.
Done.
Good.
Okay. So now I actually I have three after I thanked, and I hope I said the right people and our colleagues from FIND as well. Thank you, Adam, and my colleague Wayne. There are colleagues coming. So I think those of you that have seats, I'm sorry, but I hate people standing because in my university I had to stand a lot on that margin and I have varicosis and I think it's bad. So if the people in the middle that you have seats near you, just agglutinate somehow, please, that the margins become free for people to come. And at the point we will have to stop because there will be no more seats. And the place is sit and sit. 5 minutes, yes. With this or without this? Okay. So I have 5 minutes left because I use my other 5 minutes to do a logistical organization. So in these 5 minutes, I want to say the following. You have 2 more seats here, so I think you will have to swallow them. I'm really sorry to put you on spot, but we have people standing. So, okay. Now, I use my 5 minutes to say one thing. First of all, I want you to give a big round of applause to yourself for continuing to work and believe in the good that we do towards ending TB, please. I hope you all know how humbled or you will know how humbled I feel in speaking in front of all of you, not only because you are here and you took the time to come and be but also because you are devoting your time and your energy in fighting TB. It's not always easy, it's not always rewarding, it's not always seen, but we believe in a good, and we believe in the fact that we can change this world and make it a better place. And the new tool working groups, the new diagnostics, the new drugs, and the new vaccine are the amazing avenues for engagement. We are extremely proud, the Stop TB partnership, to be associated, or how to say, linked to the work that is done. And we are humbled by the amount of energy and neurons you are all putting on TB. So thank you. You have some more seats here. There are 2 here on the line 2 near the lady, and 1 more there. Okay. The ones following after me will have a very nicely organized auditorium. That's my purpose in life. Now, two things concretely is to say this. We are not going to easy time, okay? And the challenge we have is that we have this amazing energy and these amazing achievements on new tools, on new diagnostics, on new drugs, the new vaccines. We have finally increased political commitment coming from heads of states, from ministers of health that see and understand more about tuberculosis. All of this are coming against a background that is very worrying. It's a background of war, of unrest, of a lot of political and economical priorities. It's a background in which governments have to choose where to put their money. And it's very difficult to keep TB and as well the interest and research on the agenda. But this should not discourage. This should not mean we have to stop. We are at the phase in which we have nothing to lose. And for people, I come from a meeting at WHO, at the UN city here with colleagues from WHO and countries, and I was saying the same. We have 5 more years till 2030, right? 5 years is a lot of time. 5 years ago, in 2020 October, right, we were under COVID. We were locked in different houses. We were very worried of what will happen to us. We couldn't see. We couldn't see the way in which we will survive. And look where we are in 5 years. All this boom of digital technology, of artificial intelligence, of miniaturized diagnosis tools, of treatment regimens that are short, of 18 vaccine on the pipeline, of a lot of it happened in the last 5 years, right? There were a lot of things that happened before to achieve that. But the boom, how to say, was this. So imagine where we can arrive in 5 years. We are facing now some challenges, but I have to say that the challenges that we see, which are related to the decrease in funding and so on, are can very much drive us to some opportunities for change. It's time that countries look much more at themselves to own the TB response and to invest in the right tools and treatments and vaccines for everybody. And not all the countries will be able to do that. But this dramatic situation in which everybody found themselves led to the fact that a lot of governments had to discuss and understand what's happening. And that's why now they are discussing more than ever about sustainability, resilience, and investing in their own problem. As researchers, as the pioneers towards producing new tools and also pushing new tools out there, you should drive all of us in the TB community ahead. And you should teach us how to think in a different way. And you should look at developing tools that are not just for TB, but for other as well. And you should look at having things that are cheaper, rapid, integrated, things that are beyond TB and so on. I don't have enough time to go on all of this. What I want to say is that as Stop TB Partnership, we are having an incredible convening power, and we created and managed to have an incredible movement with us, with heads of states and governments and civil society, survivors, technical partners, and we are very honored to really try and support the working groups, particularly the new tools working groups. 2026 is unclear, but I commit here in front of all of you and in front of whichever colleagues are online, that as Stop TB, we will do whatever it takes to identify resources and funds to be able to support your work for the 3 working groups in 2026 with the very little we used to do, but we will do whatever to find that missing million that we have to put in the work of the working groups for the secretariats to be able to take this work forward, even if I have to go at the door of every private sector or at every donor to fundraise this money. With this, and because Daniela will beat the shit out of me if I continue more, and of yours, I want to thank you very much. There are colleagues on the stairs, so you can agglutinate even more. You all know what is agglutination. I don't, anyway. I know. Thank you very much, and I wish you an amazing day. Thank you.
Thank you so much, Lucica, for taking the time to run back and forth from UN City. Nobody knows that we had really a very fast walk to come here on time, and you are inspiring as usual. And said so, we need to move on with the agenda. And the next speaker is Olya Klimenko. So Olya, please. And Olya is the development leader at TB People Global, a network of people affected by TB across 30 countries. And she's now working with her team in building an AI-powered virtual assistant to ensure stigma-free, equitable access to quality TB care and support. Olya, thank you for being here. Thank you very much. A big applause for her.
I have only one slide. Hello, everyone. So amazing room today. It's first time for me and my first experience this format of meeting. I'm Olya Klimenko, and I'm not only global advocate for human rights and rights of people with TB and other social diseases, But first of all, I'm a person who faced with tuberculosis, and it sounds symbolic for me because 10 years ago, in November 2015, I completed my first therapy. So it's really emotion for me stand here after 10 years and thinking about new tools, new opportunities for people who today continue faced with TB, who need, who waiting help and waiting early diagnostic help on time and complete and comprehensive support for their way. So when we speak about diagnostic and what's important for people, as a role in community, I really believe in CLM, community-led program. And if you can imagine our planet and world and thinking that in every country we have community team who provided some digital solution for us. It's one and part digital solution, and we have global dashboard. And in real time, our CLM program take opportunity for us, received messages from people who face with TB about their experience, about their barriers, about their feelings, and this feedback we received in real time. So we can imagine our world and our biggest community and our information that we collect in every day. And for today, in our reality time, of course, we all dream that every person with first symptoms, tuberculosis symptoms, know where he should go, that believe that every human receive humanity and dignity, help, and correct diagnosis and start their treatment with all social support, psychology support, without any burdens. But for today, in our reality, we can see that every person we said and we receive thousands and thousands of messages around the world. So our data, it's not about from 100 people, or it's really biggest number challenges, information regarding these challenges from people in every country. And of course, for today, unfortunately, we said that we haven't early detection programs. It's not only about medical issues, location from hospitals, our capacity from medical doctors, or it's about every person who not yet thinking that tuberculosis is about everyone from us. So people, for today, people don't receive early diagnosis. Unfortunately, we see that diagnosis is not free for people. And of course, social and material barriers, it's challenges, it's a big barriers for people continue their way before start treatment. It's the first step. When people received diagnosis and thinking that they have tuberculosis, they face with stigma. Stigma around the world is the biggest challenges for today. From social, from medical, from people lost job, people lost their social activity life, people faced with a really big stress and bad feelings with them because they receive TB diagnosis. It's a big challenges for today for people continue their way. So we can present for people new tools, new innovation, but it all doesn't matter if people afraid receive treatment and hear their diagnosis. And of course, we need thinking when we present for people new opportunities. We need thinking regarding the services, where they can receive the services. Because for today, location barriers, transportation barriers is the same challenge for people. But I really believe, not I'm, but community in general, that together we can change this situation. But only together, only united. It doesn't matter, community, medical, working group, only together we can change the situation in the world. And we need to start thinking regarding the stigma, and after this, regarding these new tools. Because world free from tuberculosis is not world free from disease. It's a world where every person who faces with tuberculosis is only a person who need help, comprehensive support, and understanding from each of us. And in my experience, my daughter, she was 7 years old when I received my diagnosis. Unfortunately, her way was the same as mine. And unfortunately for today, with all our progress, children face with really big challenges and burden, the same with adults. And that's what we need thinking when we thinking about some tools for people. But I believe we can do this and we can win TB, and of course not for 2030, but I believe we can do this and we must do this. Thank you for this opportunity.
Thank you, Olya, and we are now moving on with the agenda of the New Diagnostic Working Group 90-minute symposium. Let me start by saying that this has been a very difficult year for all of us working in TV, and has been very difficult also to continue the work of the working group. And we were puzzled few months ago, and we were discussing how we could have organized this symposium without any money and financial support. We were facing the challenge to skip the year or to continue. And we had the idea to go on whatever it would take. And with the help of Adam, that took the place of Morten as a co-chair of the chair of the New Diagnostic Working Group with me, and the great help of Morten that organized and gave us the possibility to meet here, we decided to go on and to have the other new tools working group on board. So I'm absolutely delighted to be here today and to introduce the next speakers that, as a tradition, is Adam Penn Nicholson, and he will introduce us the new tools to diagnose TB, an accelerated pipeline. After that, we will have time. Adam is now the deputy director and head of the TB program at Find, and it doesn't need to.
Thank you, everybody. It's really great to be here and see so many friendly faces again. After so long, it has been said already. I think it's been a bumper year, lots of challenges for all of us. And to see you in the audience is especially rewarding at this point. And for all the Zoomies out there as well who couldn't make it this year but are still joined, I really appreciate you signing in, checking in, and you are in our thoughts, even though you're not in the room today. We can only do this together. Right? I will talk a little bit. I mean, even though it's been a difficult year, there's still so much that's going on, right? And so I will talk a little bit about the pipeline. It is rich. I have a lot to say. I have a lot of slides. So somebody's gonna have to keep me realistic here. And I wanted to start with this one. The title slide, I changed it. What I like about this is that there's empty chairs in this clip, right? And so to me, this is really where I want to be. I don't want to see people in a clinic. I don't know if this means that we're doing more testing outside the clinic, but at least there's nobody in the clinic at this point, right? So the global TB report was recently published by WHO. It showed that there were 10.7 million people who were estimated to get TB in 2024. And of these, there were 390,000 drug-resistant TB cases, 619,000 people living with HIV, and 1.2 million children with TB. It also caused 1.23 million deaths, so a slight reduction from last year, but a massive problem. 8 countries accounted for 2/3 of these total number of TB cases, with 5 countries contributing over half. Of those individuals with TB, 8.3 million were diagnosed, meaning that there was about 78% of all people received the diagnosis, and there's a gap of about 22% still remaining. But interestingly, of that, actually, only 4.5 million, or 54% of those who were diagnosed with WHO recommended molecular tests, which means that only 42% of all people who have TB are actually diagnosed with the test that we want to be using for diagnosis. So there's a massive gap that we need to approach here. And we need new tools, accurate, decentralized points of care, molecular tests, novel sample types, better drug resistance tests, AI solutions, and novel strategies, which we'll go through a bit today. So there's a couple of classes of TB, including point of care, near points of care, low complexity NATs, moderate complexity, and of course, the new targeted next-gen sequencing and sequencing solutions. And I'm going to go back a little bit. I really like this slide. I don't know if Willem and Mark, you'll recognize Angelica, Levaya, and Petrus, and Tayembet, where this was actually a buccal swab about 10 years ago, I think, from the SAPI site with Jerry Kangalosi. I don't know if you're in the audience, but this is where I think the swab will sort of started, and it's really exciting to see this come full back. So I'll go through a couple of studies. In this study, in over 1,700 participants across 8 countries, with support from the R2D2, Smart for TB, and the FEND TB network, tongue swabs were tested on experts using a consensus protocol. And what we saw here is that sensitivity was about 65% and specificity was 99%. And this is variable. I mean, the sputum smear sensitivity was about 49%. So this is something to keep an eye on through the studies, but it shows really that swabs could work with existing technology. However, they were affected by bacterial load. So it seems to work a lot better when you had high, medium, or lower than very low or trace sputum semi-quantitative values. So the new players on the block, or the old ones, as well as MolBio, have released an updated and improved chip called the MTB Tuner Ultima chip, which has hypothetical and demonstrated increased sensitivity, and with a battery-operated lysis device called the TrueLyse, which allows for sonication, it really decreases the time to results to about 40 minutes and about 5 minutes hand-on time. And similarly, Plus Life out of China have released their mini-doc MTB assay and the ThermoLyse heated vortex shaker. And this workflow is very simple to do and quick. It's low price tag instrument, almost into a point where if it breaks, it can be disposable instead of having a servicing module. And what the studies have done in this one from R2D2 and Global Health Labs and others have tested both tongue swabs, but also the sputum with the swab dipped into the sputum. So sputum dip swabs for performance. Right? And in the study, across multiple countries, and think it was, I think it was more countries. I'm sorry if I haven't showed all the slides here. Uganda, Vietnam, and India. The sensitivity was 78% on the MolBio tongue swab, and on the mini-doc from Plus Life, it was 86%. So a bit better in the Plus Life. However, with the sputum dip swab, sensitivity was 92% on the MolBio Ultima and 90% in the Plus Life. So really encouraging results overall. And it suggests that you can use either a sputum or a swab where a sputum sample may not be available. Specificity was high and error rates were low. And in another study, in over 1,000 participants in Cameroon, published by Mbuli et al. Sensitivity was largely comparable between the two platforms, with tongue swab sensitivity between 74 and 76%, and sputum swabs between 84 and 86%. And in one more study that I'm going to mention today, in Indonesia, from the evidence group in Bandung, tongue swab performance was again comparable and reflective of other studies across the two platforms, between about 72 and 73% sensitivity in both platforms. And if you look out in the tech session to come, Gavin Liao, the head of marketing at PlusLight, will talk a little bit about the PlusLight assay and the development pathway. So please watch out for that as coming. Now, these are not by any chance the only studies. There are more, and I encourage you on Wednesday morning to please try to seek out the symposium. I think it's 8 o'clock, hosted by UCF, UCSF, University of Heidelberg, and McGill, where they'll go into a lot more detail on some of these sensors. All right, so there are many players who are now committed to alternative sample types, tongue swabs particularly. Some are a bit more advanced than others, but I've listed some of them here. I think HUL out of India has a test that they can license in the derivative of the PlusLight for sale and marketing in India. And CoSara has a similar test to that for the Indian market from Diagnostics. I think interesting, and I wait to see a bit more data, is the USTAR device, the PortNet device, which is the only low-cost swab-based molecular assay that does not require a separate lysis device at this point. It uses a chemical and heat extraction. And we're still waiting to see a bit of the evidence that comes out of that from Cameroon, Nigeria, Vietnam, and Indonesia. There's some studies that are ongoing. But there's many other players who are getting into the field, and it's really exciting to see that data is progressing. Right, this is a bit of a homemade solution from Quantigen. It was a 3D printed manual B beater. It costs $10 to manufacture. It's easy to replace parts. And what the group showed is that it lyses MTB in sputum and in swabs with better or equivalent efficiency than many commercial-based bead beaters, and certainly better than just using heat lysis alone. And while this may not be implementable to stand in the field and rotate it for 3 minutes, right, especially in a busy TB lab, I think if lysis is one of the challenging features, I really encourage the developers to get in the space, because it can't be that hard if we can do this on $10 manual rotation, right? So there are solutions, but the implementation is a different question. There's also some excitement from Molbio, who have a now low-cost, fully integrated DNA extraction and isothermal PCR instrument, which is called TruePoc, and Mani Subramani will be presenting that in the tech session today, so keep an eye out to keep it going. I wanted to just highlight the Here to Home study, which is being conducted with Burnett Institute, University of Stellenbosch, FPD in South Africa, and Thinker in Philippines. This is a study in 600 participants, where the aims are to assess acceptability and feasibility of community-based screening for TB with swabs, and then in-home testing of household contacts, and with the cost estimate study. And so I'm quite excited to see this really being decentralized, going into the community, into the household, and see what we can do as the next step. So this study kicks off next month, and we're excited to see the results. Swabs by no means are the only samples out there that can be used. There's actually 3 really nice but small papers that show that oral rinse is an acceptable study, a sample type from South Africa and Brazil, mostly these studies, and in some ways outcompete tongue swabs for performance. So I think while these are small, it is a reassuring that there are other mechanisms. Interestingly, this was all done on Expert Ultra, which was not designed for tongue swabs. It has been modified, right? So it may be more of a reflection of the actual volume of sample that can be added. Right. There's a lot of excitement about cell-free DNA and CRISPR-based assays. So IntelliGenome and Kurt Well, who's in the room, will talk a little bit more about the assay from IntelliGenome in the tech session. But this is a blood-based test that I think is we're all excited to see some more data emerge. There are other sample types which the potential to detect TB early, especially in asymptomatic individuals and individuals who are unable to produce sputum, including exhaled breath condensate, bioaerosol capture devices, and air samplers that can be placed in a room. And if these are paired with sensitive diagnostic tools, we hope that we'll have a greater breadth to detect TB across the spectrum of disease. Another study I'm really excited about is the ATIS project for asymptomatic TB transmission in India and South Africa. This is under the leadership of C3IB in Indonesia and ARI in KwaZulu-Natal in South Africa. In this study, 90,000 adults will be screened, and children in those households will be assessed for TB infection over time to determine the ability of asymptomatic individuals to transmit TB. And multiple specimen types are being collected as well for evaluation, including tongue swabs, bioaerosols, breath capture, and face mask devices. The T cell activation, the TASA assay, which is, shows recent versus remote infection, and also blood for cell-free DNA and other types. And so enrollment of this study is scheduled to start in Q1 and Q2 next year. Grant Theron from Professor Grant Theron from University of Stellenbosch will present a little bit on the PREFIT study predicting the future incipient TB, where a number of different tests for finger prick blood-based evaluations were undertaken, and for both a screening use case and for predicting disease progression. So Grant will be speaking up next in a little bit. Back to urine, I think, and urinary lamb. I think this field is certainly still dominated by the determined TB lamb from Abbott, but there are, and it still has incredible use case for people living with HIV and children, but there is a need to move this to people, HIV uninfected individuals with high sensitivity lamb-based assays. We're still excited to see the developments from Fujifilm and their FujiLam assay, and I think GHIT had recently made an award to support this further. But there are other developers in the mix too, including Salus, Biopromic, and LIDA out of China with their AIM-LAM test, and many others, where urine can be concentrated, or lamb can be concentrated out of urine, and it can be cleaned before being read, either with or without a reader to increase the sensitivity. And there's also a lot of excitement about new antibody pairs and nanobodies. We can't wait to see where this emerges. But urine is not the only sample where lamb can be detected. And Dr. Ruth Grignell from Revity will present in this session, where in their assay, they've seen lamb in the blood of individuals. And so we are excited to see how this test can be moved forward to a decentralized solution as well. So I've shown a lot of platforms, but I think what's still open is the investment after COVID. There was a lot of PCR kits that were distributed, PCR instruments that were purchased, and there are many manufacturers and tests that can be run on these open PCR platforms. These are centralized lab solutions, but they can really bring down the price and increase access if we use them appropriately for confirmatory testing and drug resistance detection. But we do need to have ISO standards to ensure that these tests do meet the quality that we expect of them. There may already be existing tools for, that we can also optimize, right? And in this study out of Cameroon and also the Start for All team, what was seen is that if you take individual sputa and you pull them into a single aliquot and then run a single ultra cartridge, can you reduce the number of tests that are then required if that test turns positive? So in this case, 4 are pulled into one ultra is run, or one high sensitivity NAT assay. And then if that turns positive, then you would go back and test each of the individuals. And in this study of over 60,000 individual specimens tested across 25 labs in Cameroon, what the authors have shown here is that there was a 65% overall reduction in the number of cartridges that were used. The average time per specimen run was 23 minutes, reduced from 67 minutes, and the average assay cost dropped down to $2.79 instead of the $7.97. So if we can increase our capacity and resources, we can diagnose more people. Right. Low complexity and moderate complexity NATs still have a very important role to play in diagnosis and in drug resistance detection in sputum. And I think recently Expert XDR achieved pre-qualification from WHO, which is really an important step for wider adoption. But we have a lot of expectation from other developers as well, including SD Biosensor from Molbio and from Bioneer and moderate complexity NATs as well, to increase the detection of drug resistance. We're running out of time, Daniela. I'm going to go quickly through sequencing. I think it is already approved targeted next-gen sequencing, and there are advances in the space of regulations and operational handbooks, updates to the mutation catalog that are really increasing the sensitivity overall that we can see all these new tests that are coming out. And recently, Oxford Nanopore and bioMérieux have launched the Amport TB together. We'll skip this slide. I'm so sorry, Andrea. And just to go briefly through some of the AI solutions, there's a lot of players in the AI space for chest X-ray and computer-assisted detection or PAD. There's a lot of devices out there as well. WHO has done a tremendous job with FIND in using the validation platform to validate many of these CADs. And in June last year, 6 CADs were approved for use in individuals above the age of 15. There is now significant work to try and apply these or modify the AI to have best diagnosis in children in the CAPTCHA consortium. And as a sneak peek, I think it's doing pretty well. In the CADs that were evaluated outperform an expert radiologist with great readings overall, but I think there's a lot of opportunity. And please do make note of these talks on Thursday and Friday from the CAPTCHA Consortia. I'll put this in there's a shared folder that you'll be able to access, but I encourage you to go and see these talks to gain more. And lastly, just the other AI tools are cough sound analysis. There's a repository of over 700,000 cough sounds that developers can use. There's also points of care ultrasound, which is promising because it can help identify diseases beyond just TB. And then there's digital stethoscopes. And I think Max Rath from AI Diagnostics in South Africa will talk a little bit about their device. 2 last slides. The one is just to punt the FIND DX Connect portal, where we have updated it to add 44 new tests through 2025. There are now 169 tests just for TB alone from 103 manufacturers. You can get all the details of the regulatory status and the performance. I think it's an excellent resource, and we encourage developers to please submit new data and status updates to keep it relevant to the viewers. And lastly, the FIND Biobank is an incredible resource of well-characterized specimens. Over 20,000 samples have been distributed in the last 5 years, 75% of which are from TB. And so this is a huge tool to help support and stimulate development of diagnostics. Right, and I thank you all for your attention. In summary, I think there's a lot of new classes of diagnostics, but we need that real-world evidence and implementation data. We need greater investments in capacity, and we need to get integrated testing to the, out of the centralized labs and into the decentralized. Thank you very much.
We can sacrifice 5 minutes from the coffee break to have few questions for Adams by the audience. Any questions?
I'm around all week though too.
It is going to be around all week. But it's, well, if there are no questions, then we can move on with the next speaker. And wonderful. Here we have, so you are, okay. So we will have Professor Manu Pai from McGill that is going to introduce the next session. That is critical path for introduction and scale up of new TB diagnostic tools in 9 countries.
Thank you, everyone. I endorse what everybody has said so far. To have all of you here itself is a huge deal in the midst of this crazy funding crisis and catastrophe that we are all witnessing. So TB itself has high mortality. TB products also have high mortality, right? This is a beautiful graphic that Luchika and Jackie published years ago called the Valleys of Death in TB products. And I think we've tried to kind of, in about 10 minutes, I could populate, I don't know how many dozen tests in the 2 valleys of death. I think every test on that database, 160, belong in one valley of death or the other. The only product that I know of, a diagnostic, that has truly escaped the valleys of death is microscopy, which is very damn sad to say about our field, okay? Because you just saw Adam's presentation, even molecular WRDs are barely reaching 40% of the population that is intended to test. So if you use that as a yardstick, virtually no test other than microscopy has escaped the second valley of death. And most products that Adam showed us now probably be in the first valley of death. They're not even on the market yet. This doesn't mean we have to accept this as a reality. And I think that's what the presentation is all about. Could we really do something to throw a lifeline to some of these good products and pull them out of the first valley? And once they're on the market, can we get them past the WHO endorsement and actually get country programs to adopt them in a timely, fast manner and move it forward, right? Not only are the values of death worrisome, the timeline is very worrisome. Now, many of you remember 2010 was a huge event for us in the TB community. That is when the first molecular automated NAT gene expert was endorsed. I remember writing a New England Journal editorial calling it a game changer, okay? I'm not sure if it was a game changer or not, but we are excited, right? And 15 years later, we're still operating at about a 40% uptake. That is not saying good things about us as a community that's hungry for implementing new deals. Certainly nowhere close to HIV in terms of their ability to take and run it. Lenacapavir was, the trials came out a year or two ago. They've already licensed it to countries, dropped the price from $40,000 to $40. They're just chugging along like crazy, and we are still messing around 15 years later. So with that said, that's the context. We now have tongue swabs, all of the wonderful stuff that Adam spoke about. Could we do something about the critical path? Shorten it, streamline it, stop duplicative efforts. We had a whole meeting this morning. Could we not have 800 diagnostic accuracy studies? Can we do other things that is required for the WHO endorsement? That's the thinking we're bringing here. So we have now mapped the critical paths for adoption and scale in all of these countries and an entire region, which is the Africa region. So at this meeting, you have Mikashmi handing over this card for you, so you can scan the QR code. If you go to this open access website, all 9 countries' data is available for you, along with the entire Africa region data are available for you. So in this presentation, we will only give you the top level results. But if you're interested, come join us and listen to all 9 country data on this workshop on the 18th. So I'm going to now ask Mikashmi to first show you the methods that we use for the critical path analysis, and then she and Marguerite will present the results.
Thanks, Madhu. So just talking about the methodology that we took to do this critical path analysis for all these different countries, it was still a very structured and an iterative process that we did for all these countries. We started off with mapping out relevant stakeholders, whom do we need to talk to, who are relevant, starting from national TB program managers, manufacturers, policymakers, implementers. We went out, we also did a lot of desktop research on understanding what currently exists in the documents, and then did interviews, workshops, and consensus building exercise so that it is not just a theoretical tool that will exist in a document or in a publication, but it is also something that people can use, especially manufacturers and innovators who can use and see if we really want to introduce a product in any of these countries, what do we need to do? So For Asia, I'm going to cover Asia very quickly. So we had these 4 countries where we did the work: India, Pakistan, Bangladesh, and Indonesia. And we have a whole detailed symposium coming up tomorrow, which I invite you to attend. So here I'll be covering very overarching work that we did and quick snapshots of each of these country pathways. So for India, this is a very small subset of the entire and detailed critical pathway, starting from a regulatory approval and showing different stakeholders in this entire validation platform. So we have the regulatory authorities, ICMR, CTD, the National TB Program, and how does a product really move from that regulatory approval to an actual uptake in the country and procurement. So for India, there was an in-country manufacturing, which was seen as an enabler, and also availability of independent protocols and transparency of doing these evaluation and putting those results out on public websites was seen as an enabler. A very small subsection of the Pakistan CP as well, we did see that having a WHO policy recommendation was a huge enabler for Pakistan, for any country to be, any manufacturer tool to be adopted in Pakistan. And even if there is no WHO policy recommendation, but if there is an SRA approval that has been done on any tool, that was an enabler as well. For Bangladesh, we saw WHO endorsement was a key enabler. But one of the important things here was that they actually go through the guidelines, and if the WHO guidelines, they don't have operational research done in high TB burden countries, they would actually have an in-country operational research being done, which takes about 1 to 2 years. For Indonesia, this was really interesting because there was an existing pathway that was broken, as every pathway in every country that we see. But now we did see during the course of this project, there was a co-creation pathway that was being developed. So there are stakeholders sitting with the NTB managers and trying to develop this while this work was ongoing. So we did see a critical piece here that pre-market clinical validation was important for any tool to be considered. And even if there is no WHO recommendation in this that exists for that tool, if the technology can really help reduce the diagnostic gap in their setting, that was a key enabler for Indonesia. So now we did all this work. There are detailed reports that we will share tomorrow in the symposium. But now we wanted to synthesize all of this together to see what are the key themes and domains that we can synthesize these findings into. So we had these key themes to look into, and each of these themes had sub-questions. So starting off, for example, with product origin, we wanted to see which products are each of these countries really using. So most of these countries, they are happy using imported technologies. However, we are seeing a shift and a major shift in India where they are trying to focus majorly on in-country manufacturing. And we did ask the question, have countries really used any other technology that has been developed in-house? And we did see yes for both India and Indonesia. For regulatory requirements at the global level, for all of them, a WHO recommendation with a PQ certification was an enabler. It was good to have it. But it is not a strict requirement. It is definitely a requirement if you want to do a global fund procurement, but not necessarily to put it and introduce in the country. And India was the only country with MolBio that actually adopted a technology without a WHO recommendation, but there were a lot of in-country validation studies that were done. For recognized regulatory authorities, we do see, other than WHO and PQ evaluation, all of these SRAs and CE certifications were needed in all these 4 countries. At the national level, the top row basically shows the different regulatory authorities, and along with these regulatory authorities are national stakeholders, the NTPs and other important agencies that play a key role in getting a product into the country. And the WHO Global Benchmarking Tool is a tool to understand the maturity level of the national regulatory agency in each of these countries. So this is how the NRAs in each of these countries have been recognized by the WHO GBT. For now, we also wanted to understand, okay, how quickly can we get this done in each of these countries? A question that all manufacturers really want to know. So we did see a huge range from in Indonesia, it was ranging from 4 to 6 months to about 20 months in India. Once you do get a market authorization certificate, it is valid up until 5 years in all of these countries, which is renewable. One common thing again was that local validation is important and key for each of these countries. In Bangladesh, the main focus was on operational research rather than just on accuracy. Now we wanted to see what are the key enablers, what has really helped a technology get into these countries. So for India, it was standardized protocols, having more transparent results, being available online, and actually having an online platform where you don't have to do a lot of paperwork was seen as an enabler. For Pakistan, political incentives, using tools like DNO to understand where should I put my tool was an enabler, and they're using it real time. For Bangladesh, having supporting data from high TB burden countries was a key enabler. And lastly, barriers. So we did see that there were key barriers that existed in all of these countries, as we do expect. Not having an online platform was a key barrier, as was seen in Pakistan. For India, not having any standards currently that exist for AI tools was also a barrier. And then for Indonesia, it was interesting to see that although preclinical market validation is important, but it takes a long time because there are not enough standardized labs to do those kind of validations, which is all of this is still a work in progress as we speak. I'll now hand it over to Marjorie to talk about Africa.
Thank you. So Africa, we did the same work across 5 countries. We just finished with Nigeria last week. So it's a diversity of the AP and also economic kind of background. Our approach was the same. We had a standardized questionnaire, and we aimed to also derive roadmaps for each of the country to facilitate introduction, market entry, and uptake. So we have the same type of table. So if you go on the website, you can have all the details. That's the approach. But the key here is that you have established national regulatory authority in each of the country. They're accessible online as well as the guidelines. Africa is very dynamic now with regards to regulatory capacity strengthening. So as I'm speaking this table, Ethiopia is now level 3 as well, right? With South Africa and Nigeria, and if I'm presenting again in 1 month from now, it's probably again. So that's a positive thing. What is important also to know is that all those national regulatory authority are using what we call reliance pathways. So they have established committee for reviewing technical dossier for medical devices and in vitro diagnostics, but they also rely on the decision of more stringent national regulatory authority. So actually, when you speak to the national regulatory authority, they will say, yes, of course, WHO PQ or recommendation is an enabler, but strictly speaking, we can approve also without. Though in real life it doesn't happen because it's needed by the National TB Program, also for implementation and access to funding and technical assistance. And we have regional harmonizations also in place. Yeah, so the same here, you have the timelines. I will go in more detail in the other slide. So that's an example of how it's happening actually. So here you have the national regulatory approval. That's for Gabon, my country, which is quite simple. So that's the one I'm using. But basically you can see what is happening. I can point. But so if you go, you have a new TB test. So you can see that if you have WHO recommendation of PQ, you know, you're going straight to the special authorization of import. So it's an abridged pathway expedited. Otherwise, it takes much longer. So as Mikashmi was saying, it can take anywhere between. Okay, yeah, thank you. So, excellent, Daniela. So, maybe I'm not talking.
Point it at the screen in front of you.
Or you can point at the screen.
Yes, that one.
Oh, yeah. So, okay, so you have the, hopefully, no. So anyway, so just walk with me. So you have a new TB test, you go to the WHO recommendation, and then you go straight to the special authorization of import, right? On top of it is in French because Gabon speaks French. And then otherwise, if you don't have that in place, it's a longer pathway because you have the National Committee of Experts, They provide a recommendation to the Minister of Health, and whether he approves or not approve that recommendation, then you can have the special authorization of import. Yeah, and then you have the marketing authorization. That being said, so that pathway can take anywhere between 3-6 months, even plus, right? But luckily, as I was saying, you have what we call the collaborative registration process with WHO. So this is bringing, and the Reliance pathway is bringing your approval timeline down to 90 days. And then when you have, and it's important to know, for example, Ethiopia considers TB, especially drug-resistant TB, as what they call a public health emergency. And so you can get approval in as little as 10 to 15 days. Yeah. No. Pre-market evaluation plays a big role. So having what we call evidence generation, either upstream or downstream of approval, regulatory approval. So here we have Ethiopia, and we see the example of what happened with the TrueNat platform. They were part of a consortium with FINE for a multicentric evaluation, performance evaluation validation study in March. And we can see that actually what this means is that Ethiopia fed into the GDG, Guidelines Development Group of WHO. And 1 month later already, the National Regulatory Authority had approved. So it really shows that, you know, it's accelerating and synergizing. And then you have the uptake into TB policy and implementation, which is ongoing as we speak. The same, so Adam presented really, we have a very dynamic ecosystem for research and development in South Africa. And what is interesting in South Africa is that the National Regulatory Authority is now putting in place the pathway for approval of new diagnostics and medical devices, in vitro diagnostics and medical devices. And they're really leveraging this existing ecosystem whereby if you do not have the WHO recommendation of PQ, you have the possibility to leverage the evidence which is being generated in the country to feed into the approval process. But it's also happening downstream where you have, it's called assay validation, but it's more assay verification, which is done by the Health Technology Assessment Unit, which is kind of the door you need to open for the test to be deployed into the national network of laboratory, NHLS, in South Africa. And this process takes quite a bit. So we saw between 90 days, if you have a WHO PQ in place, to 12 months. Something that sometimes we do not consider is the role of the private sector here in South Africa, because they do work with the national TB program and to validate as well. And what is happening, they fast track because they do not wait for the national policy to be in place before implementation. So that is something to consider also for manufacturer as an alternative entry point. And I will be ending soon with 2 slides. So there is really an opportunity in Africa, and that is the African Medical Authority agency, which has been set up, is being operationalized. And what it is they're doing, they're synergizing in one way with WHO recommendation and PQ. So if this is in place, because they have regulatory, they're working with the national regulatory authorities on the continent, all 54 countries, so they can really advocate and speed up approval. And in case this is not in place, so they are setting up currently, it has been done over the last year, a joint review and listing process. And this has been put in place for outbreak-prone pathogen. And what we saw, what this means is that, for example, for Mpox, when that continental review process and listing was completed, just 9 days later, the South African Regulatory Authority endorsed the approval. So we see that if this process is also used for TB diagnostics, it will really speed up. And it's also an entry point, very importantly, for local manufacturer. Getting all the way to WHO PQ can be a big step, but that process is accessible, and they're really advocating for this to be used. So our recommendation we will be presenting tomorrow, and you can also access on the website, but really to leverage initiative for strengthening and streamlining processes regulatory processes, for example, using the WHO global benchmarking tool as it applies now to medical devices and in vitro diagnostics, transparent evaluation protocols, enhance again engagement between the national regulatory authority and the manufacturer. Because as I said, everything is out there online, but manufacturers are not always aware. So that engagement is really key. And advocating for political commitment, resource mobilization, donors and stakeholders, partners to really support expedited and synchronized regulatory pathways, harmonization mechanism, as I've explained, and synergies as opposed to duplication, and support through pilot the uptake at country level. And finally, for manufacturers, ensure please that your dossiers are complete when being submitted, otherwise the pathway, the timelines are really extending forever. Being aware of what is happening, as I said, for example, in Africa, it's very dynamic. Consider temporary pathways to procurement eligibility, such as the Global Fund ERPD, and please reach out, especially at early stage, to those in-country incubators and diagnostic hub, which can really promote adoption as explained. And I'm ending here. Thanks a lot.
Thank you, Marguerite, and Mikashni for that. We'll make up some time. I'd like to introduce Professor Grant Durand from the University of Stellenbosch, who's working on diagnostics, on microbiome, and on transmission. And he's going to talk to us today about the pre-fit project for incipient TB. Over to you, Grant. Oh, and may I also just ask, I think in the event to try and save some time, all of the manufacturers and developers who are speaking in the next tech session, perhaps I can invite you just down to sit at the table in the front, you too, Claudia. And then I think that'll give us a little bit faster transition between them. Thank you.
Thank you. Okay. Good morning, everybody. This is going to be a very quick overview of a study called pre-fit, which is recently completed. This study was done in South Africa and Uganda and Mozambique, together with partners in the European Union. And it was really centered on this question of, can we predict who amongst exposed people are most likely to go on to develop future incident TB? And importantly, the primary question was focusing on using tests that were in development or indeed actually on the market already. So what was the sensitivity and specificity of these near point of care tests when done on finger prick blood? Both screening, in other words, the detection of co-prevalent bacteriologically positive TB in contacts, as well as for the prediction of future incidents TB. And crucially, apologies for that. Okay. I figured it out. So the main test included in the study was the Gene Expert Host Response cartridge, which is really predicated on decades of work from TB progression cohorts, where initially very complex multifactorial host RNA signatures that predicted progression to TB were identified. Many of these were subsequently refined in different assays. And this cartridge made by Cepheid uses a modified version of the Sweeney-3 host RNA signature that is calculated using that formula there, which is also known as the TB score. In addition to the Gene Expert Host Response cartridge, which was a research use only product done at the near point of care environment, this is basically a caravan next to a clinic. We also did point of care C-reactive protein testing, which is using the Lumira DX platform, which has subsequently been bought by Roche. And we also did point of care hemoglobin testing using the HemaQ platform. In terms of a very brief overview of study design, we really use bacteriologically confirmed index cases as a gateway to accessing household contacts. All the household contacts received the candidate assays on finger prick blood. If the contact was symptomatic or could naturally expect a red sputum, they received bacteriological testing, typically in the form of gene expert and culture. The candidate's investigational assays were repeated at month 6, as well as the sputum microbiology at month 6 and month 12, with sputum induction if you were symptomatic. And finally, X-ray was done at the end of the study. And throughout this, we were checking for any passive diagnoses that happened outside of the study, but routinely within the health system. A brief comment on the analytical approach that was used. This is a massive data set, but this is the analytical approach for the analysis that I will be presenting today. We did receiver operating characteristic curves at thresholds based on pre-specified sensitivity, specificity values based on the World Health Organization target product profiles. This was adopted for the Gene Expert HR test as well as the hemoglobin test. And for CLP, we used WHO recommended cut points of 10 and 5 milligrams per liter. And these cut points, sensitivity and specificity thresholds that we analyzed the 2 use cases for, which was screening were 90% sensitivity and 60% specificity, and for prediction was 75% sensitivity and specificity. These represented the minimum thresholds recommended by the WHO for these 2 use cases. And importantly, I need to emphasize that this was done in people who had microbiological reference standard information, who were people who were symptomatic or who could expect a red sputum. So this is data from just over 3,000 contacts. So from 3,000 contacts across 3 countries, we found we found exactly 42 co-prevalent TB cases. So this is bacteriologically positive TB and some clinical diagnoses in people at baseline. And really beyond day 14, that in the predefined analysis was the time point for the start of potential incident TB. And we identified a total of 102 incident cases over the duration of follow-up in the study. This is a graph showing the time to TB in exposed contacts. So these are people who do not have co-prevalent TB at baseline, and on average, approximately 260 days passed from the index case diagnosis to the contact being bacteriologically confirmed with TB. But you can also see that this is highly variable. There's some patients who develop bacteriological TB very quickly, and there's some people who took years. So the areas under the curves for the 2 different use cases for each assay are shown here. Expert HR had an area under the curve of over 90% for screening and just over 70% for prediction. CLP was not far behind in both instances, with the confidence interval for the screening use case as significantly lower than expert HR, but not by much. A similar trend was seen for prediction, and hemoglobin was a significant predictor of both screening and incident TB, but was not very promising relative to the others. So for the purposes of this talk, I'm just going to take that out of the conversation. So what does this translate to in terms of sensitivity and specificity? Well, in the screening use case, which is again detecting TB, co-prevalent TB in household contacts, at either of the WHO recommended thresholds, we had very similar sensitivity and specificity, 91% sensitivity and 75% specificity. But just to explain the color coding here, the green means the point estimate is equal or in excess to the WHO recommended threshold. Yellow signifies that the confidence interval crosses the threshold, and red means that neither of the previous 2 things are true. C-reactive protein at a threshold of 10 did not meet the WHO threshold with 65% sensitivity, but at 5 milligrams per liter, the confidence interval of the sensitivity estimate did in fact reach the WHO recommendation. And specificity in both cases satisfied what the WHO recommended And in the bottom right corner is just a reminder of what those particular thresholds are. So for prediction, expert HR unfortunately did not have sufficient specificity to come close to the WHO target product profile recommendation. And when you optimize for specificity, the sensitivity did not come close. And the CRP had a similar problem, but was not nearly as sensitive as expert HR, certainly at the 10 milligrams per liter cutoff, but at 5 was actually quite close with fairly similar specificity. So in summary, this was the first study to evaluate near point of care tests for incident TB. Expert HR met screening criteria, and CRP had highest specificity with worse sensitivity, which was just below the target product profile. Expert HR met prediction targets, but CRP did not. And is this really worth the cost, right? This is a test that is potentially dozens of dollars compared to a test that is already on the market and costs $1 or $2. And thinking about these findings more and really reflecting on what they meant, it's interesting to wonder if this finding is actually surprising, right? So when you go back to the original papers that developed these signatures, and especially when you look at independent systematic reviews and meta-analyses using the publicly available data, they report areas under the curve for prediction over 0 to 6 months of 77%. And what we found in the study is 71%. So, you know, this is actually testament to, I think, what is technologically a very good product, right? This is host RNA accurately measured by nurses very close to clinics. It's unfortunately, I do not think that the biomarker is certainly specific enough in this case. This data might change a little. We incorporated some of the clinical diagnoses and the chest X-ray results, but it really illustrates how important it is to, from the outset, even in the discovery phase, measure biomarkers and discover new biomarkers alongside easily accessible comparators like CRP. And expert HR may indeed have some promise for prediction, but I think its costs clearly need to come down. This was a study in very high burden settings, other use cases might be different. And crucially, this really points out how this is still an area for new biomarker discovery. But this is probably the last time you're going to be able to do a study like this, right? Because the ethical imperative to put exposed household contacts onto tuberculosis preventative therapy is now very, very hard to get away from, right? So PREFIT, at least, is maybe the last study of this type, certainly in a setting like Southern Africa. So I'm thankful to the organizers for the invitation to speak. I'd particularly like to thank Frank Kuberlins and Shima Abdulgada for their prominent roles in the project, as well as all the important partners that are shown there, as well as the funder. Thank you.
Thank you very much for that. I think we will save some questions for the end. And we will move forward now with the tech session for the developers. I'd like to introduce Dr. Kurt Will from IntelliGenome. Actually, that's okay. Well, you are the Vice President of Partnerships and Strategic Alliances at IntelliGenome, and has brought over 20 years worth of diagnostic and life science experience, having worked with Siemens Health Engineers, QIAGEN, and Danaher. And the floor is yours. Thank you. Yeah. Where do I control the slide?
Great. So I'm Kurt Worley with IntelliGenome. We present to you our CRISPR-TB cell-free DNA lab-in-tube TB test. So the CRISPR-TB lab-in-tube test was designed with the needs for a WHO target product profile for a non-sputum based, rapid non-sputum based test. Ideally, in extrapulmonary TB, children with the intent to initiate treatment at the point of diagnosis with minimal sensitivity and specificity compared to current PCR methods, a small, portable, and handheld instrument and a desire to have the ability to distinguish between latent and active TB. So CRISPR-TB technology leverages both a cell-free DNA blood test and CRISPR diagnostic technology. The cell-free DNA blood test uses 0.2 milliliter sample and can detect extrapulmonary TB, and in non-sputum samples such as blood, which is very important for children. The CRISPR technology targets a genomic sequence that is prevalent in almost all mycobacteria, bringing it at a high sensitivity and specificity. So when you look at this continuum here, you see that when replication starts occurring in an asymptomatic patient or incipient TB, the immune system becomes dysregulated and starts to fight that replication. That fight results in cell death, which releases DNA fragments. It's those DNA fragments that allow CRISPR-TB to be a biomarker of active TB disease. So there are two main components to the lab-in-tube test. There's a lab-in-tube, a single tube integrated assay with all of the lyophilized reagents in one tube. On the right-hand side, you see the portable battery-operated analyzer, which provides temperature control, fluorescence detection, results analysis, and a readout. So let's walk through the workflow. You can actually use both saliva, sputum, and blood with this test in a low resource setting, like a clinic. You add the sample to the lab-in-tube. It goes through a 15-minute sample prep procedure where lysis and inactivation occurs. The DNA is then transferred from the lysate to the reaction membrane, which contains the lyophilized reagents, through a double-click plunger mechanism. The tube is then added to the analyzer, where the reaction is complete within 15 minutes, for a total turnaround time of 30 minutes. Global validation of the CRISPR technology has been done with both the benchtop laboratory-based test and the lab-in-tube test across multiple diverse cohorts in both adults and children across blood, saliva, and sputum, with consistently high sensitivity in both pulmonary and extrapulmonary TB, along with very high specificities. In addition to the real-world validation data, the CRISPR technology has been evaluated in drug treatment monitoring. The data here represents a pediatric cohort of 26 children with pulmonary and extrapulmonary TB. The chart on the left-hand side shows a decline in positivity rate from a baseline of 81% to 6%, showing CRISPR-TB's correlation to treatment success. On the right-hand side are 4 examples of patients in that study. The first one is a child of 4 years old with extrapulmonary TB, showing a very rapid decline after the first month. In the second patient, a 3-year-old with extrapulmonary and pulmonary TB, showing a nice gradual decline towards treatment success. The third patient is a child with drug-resistant TB, showing the difficulty in achieving treatment success. And the fourth patient shows CRISPR's sensitivity, I guess I'm up, in a poorly adherent patient. To summarize, we feel that the CRISPR-TB lab-in-tube test addresses the target product profile for a rapid biomarker-based non-sputum test with along the lines of sensitivity, specificity, turnaround time, portability, the ability to distinguish latent and active TB, and a low cost per test along with a low cost per instrument. A lot of data in 5 minutes. Thank you very much.
Thank you, Coach, for getting us through that one. Great job. I'd like to introduce Mani Subramanian. He is the Group Product Manager for MolBio, with over 34 years of experience in the IVD industry. And over to you, Mani. This one first.
The time is still not starting.
That's okay.
Thanks, Adam, for the introduction. Right,
Yeah.
okay. Thank you so much, everybody. As Adam just pointed out, I am from Innovate Diagnostics. What you see here is TruePOC, which is an integrated NAT true point of care device. We all know that tuberculosis continues to challenge us where our diagnostics are the weakest, which is at the last mile. Even though there is a lot of progress, we have seen that some people are still diagnosed too late or not diagnosed at all. And that is the pain point that we have been working in MolBio. So the critical question that we have been asking ourselves is, what if a high quality NAT can be run at the true point of care by a frontline worker with minimal hands-on time, no platform as it is, very integrated, portable, and eliminates operational complexity. And what we have been achieving on that score is that with the objective in mind, we have developed the TruePOC, along with, in collaboration with the Gates Foundation, an integrated sample to result NAT platform designed specifically for decentralized TB testing environments for active case finding. So I'll take you through some of the capabilities of this technology. So you can see that it is an integrated sample to result cartridge. The entire process is enclosed, lysis, extraction, amplification, and detection. No additional steps, no user intervention required. Ultra portable, lightweight, 8 hours of battery in the feed. No need for charging, in between. Fast run times of less than 25 minutes, which enables same visit decision making. And inbuilt QR reader, real-time connectivity. You've seen that all of those reassured criteria are listed on the site, and that is not a checklist added as an afterthought, but it was added before in terms of the design itself. The protocol or the workflow is as simple as it gets. Add the buffer into the cartridge, insert the tongue swab, and insert the cartridge into the TruePOC device, and results in 25 minutes. No extraction, no pipetting, and being a closed system, no cross-contamination risks. For frontline health workers, it is as simple as conducting a rapid test, but with the clinical power of molecular diagnostics. So what we are actually seeking to impact is to detect TB earlier, to treat TB earlier, and to reduce community transmission. And for that, we have 3 high-value transformations. 2 minutes, sorry. One is to diagnose on the spot, equip the first point of contact, and expand reach to underserved and high-burden testes. Whether it is a peripheral healthcare center, or a mobile clinic, or a community camp, or a private GP, the TruePOC allows molecular testing to move closer to where actually people present themselves. So if you look at the TruePOC, it sits beautifully well within the MolBio's broader ecosystem of decentralized diagnostics. This includes the TrueNAT workstation. Everybody knows the TrueNAT workstation. also the true lies and our ever expanding molecular test menu. So together with these solutions, what it offers is for the programs to have a tier-wise diagnostic network that combines the high throughput at the house, whereas with a true possibility of point of care at the periphery. Thank you very much.
Excellent. Thank you very much, Dr. Willie. I'd like to introduce Dr. Ruth Brignall, the Director of Scientific and Government Affairs for Infectious Diseases at Revity. Dr. Brignall has been with Revity and previously out with Immunotech since 2019, where she's worked on T-cell TB and other immunoassays, and will now talk to us about web-based lab.
Thank you for the opportunity to speak. I'm going to talk about a product development that Revity is involved in, where we're creating a novel blood-based diagnostic for the detection of LAM from blood. So the gold standard for TB diagnosis assumes that patients have pulmonary TB and that they can produce a sputum sample. And that means that 30% of individuals with active TB are going undiagnosed and untreated. And the ones that are particularly challenging are the extrapulmonary, children, people with portabacillary TB, those who are sputum scarce, people living with HIV, and more broadly, the immunosuppressed. So we think that testing for LAM in the blood might be a more sensitive methodology than looking for it in the urine. And the reason for this is really simple. It's that LAM is shed directly into the bloodstream when TB bacteria replicates or degrades. Some of that will then be filtered through the kidneys and a small amount will be excreted into the urine. So it makes sense that the concentration should be higher if we're looking at the source where it's being directly shed, which is the blood. So how can we actually detect LAM in the blood? So this is still very early, still in product development. But initially it would be a centralized test for non-sputum producers. It would involve a pre-treatment step followed by an immunoassay. And whilst we are working on getting this into a more point of care, nearer to patient format and looking at those options, the good thing about this is that whilst the testing would be centralized, the sample collection could be decentralized, as the sample would be really stable and transportable, meaning that it can still be accessed by people in rural settings or the harder to reach populations. So we've already shown this data at a tech pitch before, so I'm not going to dwell on it for too long. But our preliminary testing looked at the potential of detecting LAM from blood in comparison to urine LAM. So 29 TB positive and 9 TB excluded donors were tested with a urine LAM test and our LAM from blood test. The urine LAM was positive in 11 out of 29 individuals. But what's key is that, as we would expect, 6 out of 6 of the HIV negative TB positive patients tested negative using urine LAM. The key findings for our test from blood were that LAM could be detected in the blood in all TB positive urine LAM positive patients, but LAM could also be detected in 18 out of 19 of the TB positive urine LAM negative patients, including all 6 of those that were HIV negative. So following that preliminary data, our current studies are focused on identifying use cases for LAM from blood. So we're currently running a prospective multi-center study in Ethiopia to really get an understanding of whether LAM in the serum is detectable in difficult to diagnose patient groups. So we're looking at a whole range of cohorts here, but for the purposes of sharing some very early data today, I'm just going to focus on the extrapulmonary and the pediatric groups. So the early data from our study in Ethiopia shows that LAM can be detected in the blood of HIV negative extrapulmonary and pediatric patients. The real key findings are that LAM can be detected in the blood in a range, in people who have extrapulmonary TB, which is in a range of different sites of infection. So we're not just looking at pleural TB here, we're looking at extrapulmonary TB occurring all over the body. LAM was also detected in HIV negative children who had active pulmonary TB. I think what's key in this data as well is that where there were children who had extrapulmonary TB, they're included in the extrapulmonary cohort, and we were able to detect LAM in the blood of those individuals as well. So whilst this early data suggests that detecting LAM from the blood could support TB diagnosis in difficult to diagnose groups who can't provide a sputum sample, as I say, we're early in this development, a little bit earlier than the other groups that are talking today, but still really exciting progress, I think. So in terms of a summary and next steps, detecting lamp from blood could be a more sensitive method of detecting difficult to diagnose groups than using the urine lamp tests that typically fall a little bit short in the HIV negative cohorts. And whilst it's unlikely that there's going to be a one-size-fits-all solution to the problem of diagnosing TB, we do think that this could be a really useful tool in diagnosing those more challenging to diagnose groups, particularly the ones who can't provide a sputum sample. Our future development is going to focus on really refining our understanding of the clinical performance, particularly in those challenging groups. You will have seen our pediatric cohort is still very small numbers, and we're not detecting LAM in all of those groups, so really looking at where we can improve performance there. And also continuing the development of this, looking at nearer to patient and point of care workflows. I think I was under 5 minutes.
Fantastic. We're getting back on time. I'd like to introduce Gavin Liao from Plus Life. He is the head of marketing, has worked for many years on near point of care instrumentation, and will now speak on the advances behind Plus Life in Europe. Thank you.
Okay, thank you. Very honored to be here on behalf of Plus Life. I'm from China. I'm Gavin Liao from Plus Life. And I don't want to introduce a brief introduction about Plus Life and Mini-Doc. I think most of you are familiar with our molecular testing. So today I want to show some roadmap to rifansine resistant, the next generation, and the roadmap of multiplex capacity of our Plus Life's product. We are also based on the same platform of product. Actually, we also know nowadays unmet demand will still exist in primary setting areas in high burden countries are still lack of accurate and affordable molecular testing. So this is the why that we leaks, delays, unrealized loss to follow up and unavoidable transmissions. This is what Plus Life's mission and visions we want to potentially empower all primary setting areas. So this I want to introduce a little bit about a Mini-Doc lab. The originating from what we want to achieve. This is we want to bring the mini lab in your hand. So this is the very small and portable devices, and we can extensively and compatible with multi-disease, or not just from TB, but at this stage we are starting from TB. And from this underlying technologies of our Plus Life and Mini-Doc product, actually we have our own patent underlying technology. We call it RAM. It is the optimized and unique desired enzyme optimization and the unique pro design that made it possible to be more specific and sensitivity compared to traditional LAM. And actually the innovations making reaction more flexible. Even the kinase infection can be detected using these underlying technologies because this is very sensitive. But we won't stop here. Plus Life, we are also continuing evolution our enzyme disease and engine using the AI-assist technologies based on the structure-based evolutions. We want to improve our enzyme technologies. So in the near future, we can shorten the turnaround time, maybe within 20 minutes or 15 minutes using a faster, and also we can compatible with various sample types like our samples, so we can adapt it for other infection disease also. So this is the product profile of the MTB text, and we accommodate some very features about the fast result and as well as accurate and affordable, even one of the lowest cost commercialized molecular testing in the world. And also beyond TB, we also want to enrich our pipeline like HPV multi-types and sexual transmitting health. This is what we had collaboration with its foundations. And maybe in the near futures, the tropical disease like any other hypothesis in the near futures, we will also want to be one of in our pipeline. So this is what we have achieved according to the article we have published. The not just our student and as well as a council also exceeds the WHO TDT criteria and much outperform the sphere microscopy and also we can bring accessible TB as diagnosis to more people. So this is some overview of milestone and upcoming projects. I think the WHO meeting have happened last week, so let's see what will be the final result. And also the next step, we have potentially to be the global fund and also have the more and more validations across the world, like TB reach weight 11 plus. And maybe in Indonesia, we also have many validations in the near futures. And following the ARP listing, we have still many commercialization stacks across the world, focused on the TB high-burden countries. And like India, this is the specific countries, we have our close partnership program. This is what we want to achieve the regulatory and the market entrance barriers. We also want to broaden the adoptions across the world. Like these countries, we want to be the futures, and other countries, we are potentially to have localization planning. And many of the next generations, we have want to upgrading our machine. And actually, nowadays, the current situation of our countries is 7 chamber cards. We want to upgrade it to 20 chamber cards. That means we can enable the powerful for the multiplex disease for the other more flexible samples. So this is some mapping of the MTB rate product. We are based on the 81 based on RDR and also as a target regions, just as the strategy as for Orchard. So maybe in the internal, some feasibility and some internal data, what we are showing here. But I won't show because we just internal data, which are very exciting to see in some mutations point. We are achieve very good internal evidence. So let's see, we will be on the target to bring the MTB reef into the market. And finally, I want to say the plus slide product, we are not just based on this, we want to achieve the test and treat in the same day because we are compatible with the flexible and extensive infection disease. And also as well as not just global health, because we are very easy to come operations, even the layperson following the instruction, like radius instruction can know how to use the infection disease. So maybe in the future, at home testing and self-testing may be a very potential to be adaptation for like infection disease like COVID areas like maybe the next COVID. So this is what we want to share today. Thank you.
Thank you, Gavin. Excellent, very exciting advances. Next, I'd like to introduce Dr. Max Roth. He is the CMO for AI Diagnostics out of South Africa, and we'll talk about the new digital stethoscope.
Great, thanks, Adam. Yeah, here we go. Thank you. So my name is Max, and for those of you who don't know us, we're a Cape Town-based digital stethoscope company, and we use AI to screen for lung diseases using sound. So just to frame a bit of the problem that we set out to solve, and I think in this room we don't need to dwell on this too much, but we set out to solve the world's screening problem. And I trained in internal medicine in South Africa and saw the issue with the screening problem in South Africa and the devastation it causes for patients and for healthcare systems. So our screening solution is called the Osseum platform. So it's a digital stethoscope upon which we integrate multiple AI models. At the moment, a South African regulatory approved AI model for tuberculosis screening, but we're looking at multiple different lung and cardiac diseases with this platform. We're ISO 13485 certified, and the product is, from a hardware perspective, is portable, low cost, very easy to use, has no consumables, and we manufacture in Cape Town, South Africa. And the AI model is consistent, trackable, the decision threshold like X-ray is adjustable and highly scalable. So our product features offline mode, which is really important for adoption in community-based settings, automated training and support, a breathing guide that helps us standardize the length of recordings and also helps patients follow the actual screening process, and audio quality checks, so we make sure that the lung sounds have actually been heard and the technique of the user has been correct. The actual hardware, high sample rate, higher than what the human ear focuses on, and we see a lot of information in audio, which is really, really exciting. a robust casing and dual microphones so that we can implement noise cancelling technology, which we've recently finished. Again, important for adoption in community-based settings. So our TB screening model trained on 80,000 unique labeled recordings. The training data set from South Africa, Uganda, Peru, and Vietnam. The current performance of our production data set, and important to mention, this is on a single K-fold of our production, model. AUC of 0.863, 90% sensitive, and at that sensitivity, 76% specific. And just to speak to some of the what information the model is taking in, this is from the FEND study. This patient on the left that you see correctly screened negative, and the patient on the right correctly screened positive. You can see how similar those MEL spectrograms look. And there's an immense, as I mentioned, immense amount of data in audio that the model is trained on. In terms of our evidence, the top study conducted by us, we conducted a case control study right at the end of COVID, recruited from 33 primary healthcare clinics in South Africa, all presumptive TB cases, and used that as an initial study to raise our seed round, which we raised last year. And in that study, 90% sensitive, 50% specific. And then in FEN study, an AFC of 0.66, 77% sensitive and 50% specific. We've learned some really important lessons from our research, the need and importance of training and training validation. So we now have automated training protocols that sit in the app, as well as training validation protocols to make sure that scope doesn't shift over time. The importance of noise cancelling technology. So we showed that noise actually confuses the model, and as a clinician, that makes sense. If there's extremely high noise, I can't listen to the chest. The performance differences across regions is interesting, and that also shows the value of validating in different regions that the model generalizes. And usability in community-based settings, as I mentioned, noise cancelling, offline mode, robustness, really, really important for adoption in community-based settings. And then data set size and model performance. As mentioned, we're quite early in our journey. We're in the thousands in terms of participant numbers in the data set. Compared to CAD, those data sets are in the hundreds of thousands to millions. So, and we're seeing big jumps in performance with the more data we have. So exciting early promise of this technology. And just to speak to some of our research and development partners, quite a few in South Africa, the FEND study that I mentioned, with TB Reach Wave 11, we will be starting shortly evaluations with those partners. They will be starting at 10 sites in 9 countries. So really, really excited about that and grateful to Stop TB for that support. Studies with PHRU in South Africa, as well as with Gates Foundation and UCT Lung Institute. And just to summarize right at the end, in terms of our value proposition, based on our performance, 60% of those missed cases we'd be able to pick up. We are showing performance in asymptomatic TB, which is exciting, again, needs validation, and 65 times cheaper than digital X-ray, which we feel is compelling. And also to mention the rest of our value proposition, as a company from a low middle income country, we focused on markets in low middle income countries. So we focus on frontline healthcare workers, nurses and community healthcare workers, able to use the product at point of care, ease of use, community and primary healthcare settings, no consumables, safe, fast, cost effective, and again, multi-disease potential. And we focus on global health priority diseases to make that impact that we want to make. Thank you.
And a really nifty device. Right, we're almost at the end. Thank you, everybody, for that. Dr. Claudio Cosso, and let you up. Claudio is a visiting scientist in the Department of Genetics at the University of Cambridge and serves as a consultant with the WHO, TB Alliance, academia, and diagnostic industry. And I'll talk today about an update on broad microdeletion, please.
Sorry. Thank you, everyone. We're going to switch to phenotypic testing, which is very different to what you've heard before. I'm going to cover a lot of ground. There's more information on the slides that you'll be able to read. It's really for you to go back and learn a little bit more. And I'd also like to thank all of the collaborators in this who've contributed to this. This was really, it's the outcome of multi-center studies, and I won't have time to acknowledge all of them. I should say that the views expressed here are my own, and the most relevant conflicts of interest I have is that I was consultant for Beckman Dickinson, which involved a collaboration with Janssen and Thermo Fisher. So I just want to start with the regulatory background that to set the scene. So UCAS now requires that any developer seeking approval of a new TB drug generate data in the UCAS broth microdilution MSC reference method if they want to get approval by EMA in Europe. And specifically, you need to design, carry out a study to set a quality control, arrange and target to set epidemiological cutoff values, clinical breakpoints that define susceptibility and resistance, and set areas of technical uncertainty. Now, the UCAS reference method is labor intensive and is not meant for routine AST. So, but any commercial developer, once they develop their own methods, need to calibrate their method against the UCAS reference method in order to seek IVDR approval. And crucially, CLSI is now also considering whether to endorse the UCAS reference method so that we have a single standard against which commercial methods are validated, and that's also used crucially for clinical trials to lower the burden for drug developers. And briefly, I won't go into details. To do a calibration, you have a set of isolates and you test them against with the reference method and your comparator method, and you look at the essential agreement bias, very major errors, and major errors. And in this particular hypothetical diagram, you see that both methods are very similar, so you'd have a successful calibration. And in this comparator method B, you have a systematic shift up, but as long as this shift is fully systematic, you'd still have a successful calibration. Now, again, in order to lower the burden to carry out these kinds of studies, and I need to thank Janssen in this context, they sponsored the establishment of a lyophilized reference collection, which encompasses phylogenetically diverse strains that cover the known tuberculosis complex diversity, and it also covers key resistance mechanisms. Because we want to make sure that the drug is equally potent against the different types of TB that are out there. And crucially, it also incurs strains that have different kinds of resistance mechanisms, because one of the questions that we're going to have to face, especially with analogs of drugs being evaluated, is, for instance, for the bedaquiline analogs, do we actually need to test the analog, or can we just keep on testing bedaquiline phenotypically and then infer resistance? Maybe if with a different breakpoint, if say low-level resistance to bedaquiline can be treated with one of the new analogs. Or conversely, maybe it's actually that one of the new analogs has a compound that's actually a better surrogate to test for bedaquiline resistance. So again, having a standardized collection will help with this particular task. In addition to that, as I said, this method is not is labor intensive. We want to really have a simplified, lyophilized method, and WHO had set up the criteria for that, and we've now come up with methodological improvements, and crucially also to get alignment between the US and the EU, because there are always slightly different criteria as to how one would use this method. And briefly speaking, to summarize the methods that have been done so far, Janssen sponsored a study that covered 4 drugs, both in the reference method and the Thermo Fisher format. So that's a full calibration. But and then WHO did a version 1 study with more drugs, but at that time, the laminate and predominate weren't ready. Now they will be on a study that's currently started. At the end, the idea is to then design a final plate that has all of the drugs that we want, and crucially drugs that also work. Because clofazimine and cycloserine appear to be tricky drugs. We have to work on this particular system. And crucially, we also want to do a proof of principle to try to see whether these plates can be used directly from positive entry tubes, because currently we've only been really using them from solid cultures, which would in many settings introduce a 3 months delay in order to be able to use these plates. So in these And hopefully they will work from positive energy tubes so that they can really complement the rapid genotypic assays that we need, because particularly for the randomidazoles and with alcohol, the resistance mechanisms are very complicated, and we'll need phenotypic testing going forward to be able to classify novel mutations. Genotype, even whole genome sequencing, will not be the end of the story. We'll always need these plates to complement rapid tests. Thank you very much.
Thank you, Claudio. And it is now time to close the session, and I would call Professor Agus Luis Susanto, President Director of Persahabatan Hospital in Jakarta, Indonesia, to give a few remarks on the needs of new diagnostic in settings. Professor.
Thank you. Yeah. Good evening, and I'm Professor Agus from Persahabatan Hospital, is National Respiratory Center, Minister of Health of Republic of Indonesia. I will reading a closing remark from our Vice Minister of Health Republic of Indonesia, Dr. Benjamin Paulus Octavianus, because he's still on plane going to here to attend the Junior Conference tomorrow. Distinguished college partner and friend, it is a great honor to join you at this important symposium in innovation to end of tuberculosis. I think find an all-organizing partner convening this platform to bring together the global partner to convene the TB community to reflect on progress and set our next milestone. When we meet in Bali last year, we collective call to greater innovation, equitable access to the new tools. Indonesia took that call forward. Since Bali, we have made significant progress. One is integrating TB screening within our national wet-free health screening program with use of digital X-ray and molecular diagnostic at community level. Strengthening our national TB information system, we use SCTB to under the Satu Sehat digital health transformation, expanding access to rapid diagnostic and shorter all-oral regimen for drug-resistant tuberculosis. Through the National Action Plan TB 2025 until 2029, we place innovation, integration, and equity at the heart of our strategy. Our vision to reduce TB incident by half and TB mortality by 1/3 by 2029. This means ensuring that every person, regardless of where their life, can benefit from the latest diagnostic, preventive, and treatment innovation. Ladies and gentlemen, to join External TB Program Review 2025 recognize Indonesia's strong progress in the systemic screening and preventive therapy scale up. The review also reminded us to donate the close diagnostic and the treatment gaps to accelerate multi-disease screening and hospital primary care integration. Our approach is clear. We must integrate, not isolate. TB services must be embedded in primary healthcare, covered through the national health insurance, and supported by multi-sectoral collaboration as amended under President Decree that's now 67/2021. Innovation is not just technology, but also social, institutional, empowering community through initiatives such as Desa Siaga TB or community-based TB alert village program, and community-led monitoring, and enable them to the active partner detection, treatment, and prevention. As we look ahead, Indonesia is preparing for the next wave of innovation, from digital tools to new vaccine. We are strengthening our research and implementation capacity, ensuring readiness to evaluate and adopt this breakthrough responsibility and equitability. This effort resonates closely with global commitment under the WHO and TB strategy, Sustainable Development Goals 3.3, and the United Nations High-Level Meeting 2023 Declaration. The Foundation for Innovation New Diagnosis, FIND, as a key global partner, continues to drive equitable access to the rapid molecular diagnostic and point-of-care innovation that directly support the WHO target of the 90% reduction in TB death and 80% reduction in incident by 2030. This global framework emphasizes the urgency of innovation, integration, and investment, ensuring that all people, regardless of geography or income, have access to timely diagnosis, preventive therapy, and effective treatment. Indonesia efforts are fully aligned with this global mission, combine local innovation and digital transformation with a strong commitment to the universal health coverage and multi-sectoral accountability to thoroughly end TB, a public health threat by 2014. Our commitment remains firm, one, to accelerate innovation that drive impact, to ensure equitable access for all people affected by TB, and to work with partners to close the remaining gaps in the diagnosis, prevention, and care. Let us continue to innovate, integrate, and make of impact so that the next time we meet, we celebrate tangible progress toward a world free of tuberculosis. Thank you. God bless.
At the end of the New Diagnostic Working Group Symposium, we have 15 minutes coffee break at this point, and Wayne, I'm looking at you as representative of the Stop TB Partnership. We have no time for questions, so the questions are during the coffee break at this point. But next year, we need to have some support and go back to 1 day symposium. We are too bad at this point. Thank you very much.
That's